Welcome back to Old School Math. Today we're going to be taking a look at solving systems of equations using the elimination method. Great method to use, and we're going to take a look at how to do that today. By the end of this video, you will be able to do the following things. Multiply an entire equation by an integer, which is going to be key for some of our equations, and you can solve a system of equations by using elimination. We're going to go over a couple notes before we get into the examples, but just a couple things to know. That this process works really well for equations that are of the same format. Y equals mx plus b and y equals mx plus b. You might choose to graph those using technology or by hand. But this, if you've got two equations that are in standard form, ax plus by equals c, we're going to see how to eliminate one of the variables out of that. You're going to add or subtract the entire equations to eliminate a variable. Now, in order to do that, or when we do that, we want to make sure that the coefficients for x are the same or y are the same. That's why the multiplication might be important here. It may be necessary to multiply one or both equations by a constant or an integer so that you can eliminate one variable. And we'll take a look at what that looks like here in just a minute. So we're going to go over a couple examples. If you've got your note-taking guide, be sure to have that out. And hit the pause button if you want to go back, and feel free to rewind and rewatch it a couple sections if that would help you out. So in this first example, we see both of these two equations are in standard form, ax plus by equals c. Ax plus by equals c. Now, if we take a look at our x coefficients, we see that this coefficient is 2 and this coefficient is just 1. If we add those together or subtract them, we would either get 3x or positive 1x. Neither one of those allows us to eliminate the x variable. But when we take a look at the y's, we have positive 3y and negative 3y. Now keep in mind, both of these two equations work as a system. That is, they work together. So what we're going to do here is we're going to take this second equation and we're just going to add it. Okay? So we can add numbers, we can add variables, we can add equations. So let's do this. 2x plus 1x would give you 3x, and 3y plus a negative 3y would give you 0y. I'm going to go ahead and write that there to remind myself that there are no y's left. And then 8 plus 1 equals 9. So the equation we actually get from that is just this, 3x equals 9. From here, we just want to solve for x. Divide both sides by 3. And we find that x equals 3. Now at this point, it's going to work a lot like substitution. We're going to take this x equals 3, plug it into either one of our equations above, and solve for y. I'm going to use this first equation. We'll do that up here. 2 times 3 plus 3y equals 8. 2 times 3 is 6, plus 3y equals 8. When we subtract 6 on both sides, 3y is equal to 2. Last thing we're going to need to do here is to divide by 3. So y equals 2/3. And just like in the substitution method, we want to take the x value and the y value and write those as a coordinate pair. 3, 2/3. So let's take a few notes on this process here. The first thing we did in this problem was we added the two equations, and the reason we did that was we wanted to eliminate a variable. So the first thing we did is we added the equations. And it let us eliminated the y variable. This won't always eliminate the y variable. Sometimes you'll eliminate the x. So that's no big deal, just a side note there. Next thing we did is we solved for x, since that was the only variable we had left. After we solved for x, what did we do? We took that value and we substituted it into an original equation. And then after that, we solve for y. and then we wrote our answer as an ordered pair. Okay? I'll give you a second to write that down, and we'll look at our next example. Now the process should stay the same. The first thing that we're going to want to do is probably check our variables here. So again, we've got two equations in standard form. Our x coefficients don't match, but our y coefficients do match. Let's take a look at this. If we added these two equations together, we'd have 5x plus x would give us 6x. 2y plus 2y would give us 4y equals 8. Well, that didn't help me because that didn't eliminate a variable. So what we're going to do here, in order to get rid of 2y, we're actually going to just take this second equation and subtract the whole thing. When you subtract, you want to be really careful with those signs there. If you had a negative in here, we know a negative would become a positive. But this should be simple enough. 5x minus x would give us 4x. 2y minus 2y would give you 0y. And then 6 minus 2 would give you 4. So we're just subtracting each term together there, right? So this is simple enough. We end up with 4x equals 4. We all know that that's going to give us x equals 1. Okay? From here, we want to take that value and substitute it into one of your original equations. I'm going to use the second one this time. We've got an x plus 2y equals 2. We're going to subtract 1 on both sides. So 2y equals 1. If we divide that by 2, y equals 1 over 2, or 1/2. Last thing we want to do here is write this as an ordered pair. That would give us the final solution of 1, 1/2. Okay? Again, the notes are going to work the exact same way. We subtracted the two equations, or we subtracted the second equation. Okay? We solved that for x. That eliminated y. We solved for x. We substitute into an original equation and solve for y. Last thing we do is we write them as an ordered pair. Okay? Now I'm going to tell you this. These next two we're going to have to multiply by a number. And when we multiply an equation by a number, we got to multiply everything in the equation by that same number. We're going to do this first one together, and I'll let y'all try that one on your own. So if we look at example 3 here, we've got 2x plus y equals 12, and 5x minus 2y equals 3. You can really multiply either one you want to here, but the goal is to get, and you could really multiply both of them if you wanted to. The goal is to get one of the variables, the x's or the y's, to have the same coefficient. Now if you look at the x's, I've got 2x and 5x. I can't multiply 2 by anything, any integer, to get 5. But I could with the y's, right? If I multiply this top equation by 2, that would turn into 4x plus 2y equals 24. Now if I look at my y's, we see they match. We could just add these two together and it is going to eliminate the y variable. So 4x plus 5x would give us 9x. 2y minus 2y would give us 0y. And then 24 plus 3 would give us 27. If we divide both sides by 9, we're going to get x equals 3. From here we can substitute this into either one of our original equations. I'm going to do the first equation just because it looks a little simpler. And notice I'm going back to the original equation before I multiplied. 2 times 3 plus y equals 12. 2 times 3 is 6. Subtract 6. Y equals 6. So x equals 3, y equals 6. If we write that as an ordered pair, we get 3, 6. And we're done. Go ahead and pause the video right now and try this last one on your own. We'll check in just a minute. All right, so we got negative 2x minus y equals 0 and negative 3x plus 4y equals 2. There's several ways that you could have approached this problem. I think what I'm going to try and do though is multiply the top equation by something so that we can eliminate the y's. It's always easier to do that than multiplying both equations, though you could do that. So I think what I'm actually going to do here is multiply this whole thing by 4. When I multiply this by 4, I'm going to get the following equation. Negative 2 times 4 would be 8x minus 4y. And 4 times 0 is still just 0. I'm done with this equation for now. Okay? So when I add these two together, go ahead and put a positive sign there, or an addition sign, so that you can remember to add these instead of subtracting. Negative 8x plus negative 3x would give you negative 11x. Negative 4y plus positive 4y would give you 0y. And then here we have just 2. Okay? Negative 11x equals 2. We can divide both sides by negative 11. So x equals negative 2 elevenths. Now let's take this back in here and substitute that for x. We can solve for y. I'm going to again use this top equation because I don't have any coefficients with y. It'll be a little bit easier to solve. So you get negative 2 times negative 2 elevenths minus y is equal to 0. We've got a fraction in there, but don't worry about a fraction. Fraction's okay. Negative 2 times negative 2 is positive 4, and it's still over 11, minus y equals 0. And I'm going to add a y to both sides. If I add y to both sides, let me rewrite this. If I add y to both sides, I'm going to get 4 elevenths on the left side equals y on the right side. So the solutions here would look like this. Negative 2 elevenths and positive 4 elevenths. So if this seems weird to you, let's substitute back in here to check our work. Okay? Let's substitute in this top equation. Negative 2 times the x value, negative 2 elevenths, minus y, which was 4 elevenths. Does that equal 0? Let me get a little space here. Does that equal 0? So negative 2 times negative 2 is 4 elevenths. Minus 4 elevenths equals 0. Yeah, that works, right? 4 elevenths minus 4 elevenths, even though that's a weird fraction. That works, that's true. Let's check this second one. Negative 3x, so negative 3 times negative 2 elevenths plus 4 times 4 elevenths. Does that equal 2? Okay? So negative 3 times negative 2 is 6 elevenths. Plus 4 times 4 is 16 elevenths. Does that equal 2? So if we add fractions, keep in mind we only add the numerators. 6 plus 16 equals 22. This is going to give us 22 elevenths here. Does that equal 2? Yes, it does. 22 divided by 11 equals 2. So we get 2 equals 2. That works. We got 0 essentially equals 0 up here. So this is the proper solution. Guys, I know we dipped into a little bit of fractions there, and we did a little bit of multiplication, but I know that you can take these steps here. If you need to do a little multiplication there, that's fine, don't worry. And if you get fractions, don't worry. Fractions are a part of math, so don't worry too much about that. I hope this video was helpful to you. If you have any questions, you're welcome to contact me. I'd be happy to help you out with this. Thanks for watching, and if you would like to subscribe to this channel, that would be awesome. Thanks for watching.